The absolute magnitude of a star has a pretty simple definition, which is the magnitude the star would have if it was placed at a distance of 10 parsecs from Earth. Now a parsec is just another unit of length, and 1 parsec is equal to 3.3 light years. By considering stars at a fixed distance, astronomers can compare the real brightnesses of different stars. And the absolute magnitude of a star is always denoted as capital M. We can use Alpha Centauri as an example of absolute magnitude. The real distance between Alpha Centauri and the Earth is 1.34 parsecs, so the apparent magnitude would be measured from Earth to Alpha Centauri, and the absolute magnitude would be measured from Earth up to 10 parsecs, and would basically be how bright Alpha Centauri would be 10 parsecs away from Earth. Using this equation, we can convert the apparent magnitude, denoted by lowercase m, to absolute magnitude if we know the distance d in parsecs to the star. We can also calculate the apparent magnitude if we know the distance and the absolute magnitude of a star using this same equation. And the m minus m expression is also known as the distance modulus. The A band is one of about a dozen of the strongest Fraunhofer lines seen in the solar spectrum. The A band at 7,600 angstroms is due to telluric lines of molecular oxygen in the atmosphere of the Earth. The A spectral class is a class of hot white stars ranging in temperature from 7,500 to 10,000 Kelvin effective temperature. The stars in this class are also known as A stars, and the characteristics that they have are strong H lines and ionized metal lines in their spectra. And for the more technically inclined, in their spectrum, the Balmer lines of hydrogen attain their greatest strength. Helium lines, on the other hand, can't be seen anymore, and some metallic lines are also present. And in late A stars, the H and K lines of ionized calcium appear. And for the A0 stars, they have a color index of 0. Some examples of A spectral class stars, or A stars, are Sirius A, which is the brightest star in the night sky, and Deneb, a supergiant. Absolute zero is the temperature at which the motion of all atoms and molecules stop and no heat is given off. Absolute zero is reached at 0 degrees Kelvin or negative 273.16 degrees Celsius. Ablation is a process by where the atmosphere melts away and removes the surface material of an incoming meteorite. Accretion is a process by where dust and gas are accumulated into larger bodies such as stars and planets. The accretion disk is a disk of gas that accumulates around the center of gravitational attraction. This could include a white dwarf, neutron star, or a black hole. So as the gas spirals in, it becomes hot and emits light or even X radiation. An achondrite is a stone meteorite that contains no chondrules. Albedo is the reflective property of a non-luminous object. So a perfect mirror would have an albedo of 100%, while a black hole would have an albedo of 0%. An albedo feature is a dark or light marking on the surface of an object that may or may not be a geological or topographical feature. The altitude is the angular distance of an object above the horizon. Antimatter is matter consisting of particles with charges opposite that of ordinary matter. In antimatter, protons have a negative charge while electrons have a positive charge. The A number is also known as the atomic mass number, and it is just the total number of protons and neutrons in an atom's nucleus. So for example, oxygen 16 has a mass number of 16 because it has 8 protons and 8 neutrons.